All right, this time we have the Desmos Unit 5, Lesson 5 practice problems. I'm going to be doing it on paper. If you got assigned it on the computer, remember it's the same thing. It's just in slides rather than on paper or whatever. So it looks like the first thing they want us to do is order the expressions by value from least to greatest. So the value of an expression is just what you get when you evaluate the expression. Evaluate has the word value in it. And to evaluate an expression just means do the math and get an answer. So in the end, really the value is just the answer. So let's just do that. Let's just see what the answers to these are. -5 minus -4. Now I don't want to minus a negative. Remember, we spent a whole unit talking about the best way to handle that is to convert subtraction to addition, but you can't just willy-nilly change a minus to a plus, right? You're going to change everything if you do that. The only way you can do it is if you invert the next number. That -4 needs to become a +4. And now what we have is -5 plus 4. Different ways you could think about that. If you like number lines, you could be thinking about 0, -1, -2, -3, -4, and I guess this right here could be -5. And if you start at -5 and then you just add 4 by counting 4 spaces that way, you're going to get 1, 2, 3, 4. You're going to wind up at -1, right? So that's one way to do it. We learned some other tricks, but I'll do it that way this time. Okay, so this time it's the same thing, but just switched around. This time it's -4 minus -5. Okay, so same thing though. Minus a negative is the same as plus a positive. I'm going to change this minus to plus. I'm going to invert that -5 to +5. And now it's the same two numbers, but this time the 4 is negative and the 5 is positive. I think that's just going to result in us getting a +1 instead of a -1. If we were to start here at -4 and then count 5, 1, 2, 3, 4, 5. Yeah, it looks like +1 to me. So I'm going to write +1 there. Okay, next we got -4 minus 5. These are the ones that I see students make the most mistakes on. And because it's really tempting to want to do 4 minus 5 and get like 1 or -1 or something. But you have to think of it as you're already starting at -4. And then subtracting 5 takes you 5 more spaces in the negative direction on the number line. So you would be counting this way. You'd be going 1, 2, 3, 4, etc. So you're going down. You're getting more negative. I prefer to think of it instead of -4 minus 5, think of it as -4 plus -5. And that helps make it much more obvious that that is -9. All right, and the last one, 4 minus -5. Let's just change that minus negative to plus positive, and I believe we get +9 on this one. And so it looks like the least one, that's the most negative, so that's going to be this one here. This one should go in your least slot. If you're doing this online rather than in the book, I think you could probably you're just clicking, or maybe you're dragging or something. I don't know. Let's see here. The next smallest one is going to be the other negative one. This one right here should be in your number 2 slot. Then the smaller positive valued one is going to go in that 3rd slot, and the biggest one is the one that had a value of 9. All right, next is the solution to -2.7 plus x equals -3.5 positive or negative? Explain how you know. Okay, we could solve it, right? We've been practicing solving these, but maybe we could just think about whether the answer needs to be positive or negative without really having to solve it. If I'm at -2.7 on a number line, which I guess would be right about here-ish, and I want to get to -3.5, which is about here-ish, and I want to do it using adding. Do I add a negative number, or do I add a positive number to make that little jump right there on the number line? Pretty sure I got to add a negative, right? So I think x has to be negative. So I would click on negative or write negative or whatever and explain how you know. Well, I would say something along the lines of negative 3.5 is to the left. Right, I'm thinking about number lines right now. I guess I don't know why, but I'm really into number lines right now at this moment. So negative 3.5 is to the left of negative 2.7. That's just another way of saying it's more negative. So in order to move left, that's just another way of saying in order to get more negative, I need to add a negative number. Boom. You want to copy that word for word, that's fine. Or put it in your own words, think your own way of saying it, whatever works for you. Okay. Select all of the equations that are equivalent to negative 2.7 plus x equals negative 3.5. Okay. Well, let's see. Let's look at the pieces of each one and see if they're exactly the same, just like rearranged, or if they change something in a way that makes it say something different. So let's look at this first one. This one says negative 3.5 plus 2.7 equals x. Could we go from this equation, the one they gave us, to this one using a valid solution step or a valid property of equality? Let's see. I'm gonna grab a piece of paper from another assignment we've done. All right, so the original equation is negative 2.7 plus x equals negative 3.5. Now, if you're already getting kind of good at solving these one-step equations, hopefully you're seeing, oh, I've got a negative 2.7 being added to my x. I want to turn that into a 0 or cancel it out, whatever you want to say. So I should add a positive 2.7 to make this into 0. So I have just x plus 0 on that one side, or x by itself isolated. But that means I should add 2.7 to the other side, right? Keep it fair, keep it equivalent. Okay, so these cancel out, go away. We have just x on this side equals. Now we could do the math here, right? We could do negative 3.5 plus 2.7, which I think is what, negative 0.8. But we could also write it out. We could write x equals negative 3.5 plus 2.7. Is that what it said? X equals negative 3.5 plus 2.7? Oh, I got the side switched, but same thing, right? Negative 3.5 plus 2.7 equals x. So this equation is what you would get if you did the first, like, kind of logical solution step. And whenever you do that and you make a new equation, that equation is supposed to be equivalent to the previous one you had. Otherwise, what are you doing if you're changing the equation, right? It should be equivalent. So I'm going to say yes to that one. I'm going to give that one a big yes. Now, look at the next one. Here, I've got 3.5 minus 2.7 also equals x. Now, I like thinking of minus as plus negative. So I'm going to change this to plus negative 2.7. And now I'm just going to straight up compare the previous one to this one. How could these be the same? This one, the 3.5 is positive and the 2.7 is negative, where it's reversed in this one. And to me, there's no way that that could be equivalent unless maybe we were dealing with some zeros or something. There might be an exception to that rule or something. So I'm going to go no on that one. Next, we have negative 3.5 minus negative 2.7 equals x. Again, I don't want to deal with minus and negative. What if we change it to plus positive 2.7? Well, now it says literally the exact same thing as this one over here, right? And we already said that this one's equivalent. And if this is the same, well, then this should be equivalent too. All right, I'm going to leave that last one for you to think about. All right, you figure out whether or not you're going to check that one. Now, I actually don't know whether or not it needs to be checked, but if you're just skimming through the video and you're not actually listening, then you're probably just thinking that I'm not checking it because I didn't check it. Yeah, I just wanted to look at it. All right, moving on. Determine the value of the variable that makes each equation true. That's just another way of saying solve the equation. When you solve an equation, you're finding the solution, and the solution is the number that, when substituted into the equation for the variable, makes the equation true. So all these things mean the same thing. Find the solution, solve the equation, find the number that makes it true. All mean the same thing. Just get that number that you could put right there and make the whole thing work. Okay, so we have 33 being added to our A, and it's gonna get us negative 33.8. And so if we were to subtract 33 from this number, it would get us back to that A that we started from. Another way of thinking about it is we want to cancel out or do the opposite of whatever operation's happening to our variable. So if 33 is being added to our A, I'm going to subtract 33 from both sides of the equation. And what that's going to do is 33 minus 33 gets me a 0, right? So now I have A plus 0 on this side of the equal sign, or in other words, A is now by itself, which we call isolated. So A is all by itself. Oops, this equal sign should not be here. That's a mistake. What I'm doing here is I'm showing my solution step when I subtract 33 from both sides. That doesn't need to be an equation. So let's pretend I didn't put that there. The next row down, on the other hand, though, that should be an equation. It's the equation I get when I subtract 33 from both sides. Negative 33.8 minus 33 is not negative 0.8. You already have 33.8 negatives, and you're going to get 33 more negatives. You get 66.8 negative. Oops, that's kind of ugly. The whole way I wrote that one was ugly. So, but I'm being like conscious of it, right? I'm looking at it, I'm saying, oh, I wrote this equal sign, I shouldn't. I forgot my negative sign at first, and now it's all ugly. I want you to do the same thing. Keep track of how you're writing these things and whether or not they're neat, and always be trying to improve. Okay, I'm gonna skip this one. I'm gonna do this one with the fraction in it here. We got C equals negative 3/4 plus 3/2. Okay, so this one's actually nice for us. They already isolated the C for us. Like C's all by itself with nothing else going on. So all our job is to just add these fractions, which we need a common denominator for. When you're picking a common denominator, you need a number that both of these denominators, 4 and 2, go into, right? A number that 4 goes into and a number that 2 goes into. You could just multiply them. 2 times 4 equals 8. 8 would work. But if we count by 2's, 2, 4, 2 goes into 4. And if we count by 4's, you start with 4. So obviously 4 goes into 4. So we can make our lives a little bit easier by using 4. And that means this fraction doesn't even have to change. So I'm just going to do some scratch work here. I'm going to use this space for scratch work. I've got negative 3/4 plus. Now I want this fraction as a new fraction that's equivalent, but with 4 as the denominator. And so if I'm taking this 2 and I'm multiplying it by 2 to make this 4, then I got to do the same to this 3. I got to take this 3 and I'm going to times it by 2, and it's going to go right there on the top of that fraction. That's 6. So 3/2 is the same as 6/4. Now I can add these. I don't add the denominators. The denominators just say how big the pieces are, which doesn't change when you put them all together. So I'm really just doing negative 3 plus 6, which is positive 3. So I have C equals positive 3 over 4. C is 3/4. All right, and I think I'll skip that one as well. So I'll leave you a couple to do without my help. This one hopefully should be pretty easy. Just remember, you're starting with a negative number and you're going to subtract, which means you get more negative. So I hope I don't see 3.3 or negative 3.3 on that one. All right, let's see here. 3.1 says plot the approximate location of x plus 4 on the number line. Okay. Well, we kind of have to figure out what are our distances here? Where is x? What's going on? So this space right here tells us this is on this number line, that's how far each one whole number unit should be. So like from here to, now I'm eyeballing it, but that looks like about the same distance to me. So 2 is like here. And if I do it again, to about there, 3 is about here. And so if I try to do that same thing the other way, all right, about there should be -1. And right about there should be -2. And so we can't say for sure, but X is approximately -2.5, right? Okay, so if we added 4, we would go, adding 1 would get us to about here, between -1 and -2, somewhere. Adding 2 gets us between 0 and -1. Adding 3 gets us between 0 and +1. And adding 4 gets us between 1 and 2. So, it's telling us to plot the approximate location. Everything we're doing here is eyeballing. We don't know exactly what X is or whatever. And so if you plot something somewhere between 1 and 2, I think you're doing all right. Now, plot the approximate location of 4 minus X. So again, we're kind of approximating everything involved here, but I think that X is about -2.5. So they want us to approximate 4 minus negative, all right, it is 2.5, because this is 4 minus X, and X itself is negative. So I got 4 minus a negative. You figure out what that is and draw a plot somewhere on there that's going to be about this value here. What is 4 minus -2.5? Once you have that figured out, about where on this thing is that going to go? All right. So I think we're done with the algebra part of this assignment. All that's left is they like to throw a little review at us, which it looks like we got some proportional relationship stuff, and then we got the explore. Now remember, the rule with the explore is you don't necessarily have to be able to solve it or finish it, but also don't leave it blank. I should be able to see that you at least tried it for a minute, put a couple numbers in or whatever. If it just looks straight up blank, I might take a point off your homework for that. Okay, so Annie's Attic is having a $5 off sale. Is the relationship between the original price and sale price proportional? So she's taken $5 off of everything, it sounds like, no matter what the original price was. It's just always $5 off. A $15 thing is now $10. A $25 thing is now $20. This doesn't sound proportional to me, because proportional should be like ratios. Bigger things should have, I should say, equivalent ratios, not just ratios. They should be equivalent ratios. And so bigger things should get bigger discounts, right? Like everything's 10% off or something. If you're telling me $5 off everything, then if I buy a $5 thing, it's free. And if I buy a $100 thing, I still got to pay 95. Like, this isn't going to be proportional. But let's remember the way that we really learned to check this, though. We would always draw a new row, sorry, a new column over here, and we would call it the X divided by Y column. And the original is our X and sale price is our Y. And then we would just do that. We would just do X divided by Y and see what we get. So let's see here, 10 divided by 15, that's the same as 2/3, or like 66%, or 0.66, 0.6 repeating or whatever. So I'm going to write it as a percent, just to do something different than what we usually do. I'm gonna go 66%. So basically this sale price was 66% of that original price. And so for it to be proportional, they'd all have to be 66%, right? But I don't think that's going to be the case. 20 divided by 25, that's the same as 4/5, right? I'm just simplifying fractions in my head right now. And 4/5 is the same as 80%. And so it's like less of a discount, right? The bigger the original price, the less of a percent discount $5 is. That's not proportional. And so I want you to write an answer here that says no, because, and then say something about the fact that it's $5 off each time, or you can say something about these ratios not being equivalent, because that's really what it's about, right? Okay, and then if the relationship is proportional, what's the constant of proportionality? Nope, there is no constant of proportionality. These numbers would all have to be the same for that to be a constant of proportionality. If the relationship is not proportional, what values could you change to make it proportional? Well, we would need the sale prices all to be so that like you're getting the same discount off of all of them, right? Like let's say you wanted to use an 80, like all the sale prices were 80% of the original, then you would need, instead of $10 would have to change to whatever 80% of $15 is. So it would match this one. I just chose this one here in the middle just because I feel like 80% is easier to deal with than 66%, right? So what's 80% of 15? You should know how to do that. You take 15 and you times it by not 80, but 0.8. So whatever 15 times 0.8 is, or 0.80. So you would need to change 10 to whatever the answer to that is. That would be one value you could change, but then you'd have to do the same thing with this 35. You would need to change 35. Not the original 35, the sale price 30. You would need to change the 30 sale price to whatever 80% of 30 is. The same thing, right? 30 times 0.80, which should just be double. The answer to this one should be double the answer to that one, because 30 is double 15. And so if you change these two numbers to whatever you get to these two answers, then now everything should be at a 20% off or 80% original price. And then you got yourself something nice and proportional. All right. Explore puzzle. Try it for a second. It looks like you're just trying to you fill in the blanks with a plus or a minus so that it makes sense. So -3 plus 5 equals 2. So that's got to be a plus. -3 minus -2 equals -1. So just go through and see if you can fill it in with the correct pluses and minuses. All right. See you next time.